Hey everybody, I wanted to do chapter 10, number 48, to talk about energy stored in capacitors. For these types of problems, the first step we want to do is find our capacitance total for the system. And all of these capacitors are in series, so the total capacitance is going to equal to 1 over 1 over 60 plus 1 over 30 plus 1 over 20. That is equal to 10 microfarads, or 10 times 10 to the minus 6. Next step, we want to find our Q total, or total charge for the system, which is equal to your capacitance total multiplied by your voltage, which is equal to 10 times 10 to the minus 6 multiplied by 120, which gives us 1.2 millicoulombs, or 1.2 times 10 to the minus 3. That looks like a terrible 3, sorry. Let me fix this real quick. 10 to the minus 3, there we go. Now, from there, we need to find the capacitance for the voltage for each capacitor to find the energy stored. So we will start with V1. That is equal to, if you remember from the previous problem, it is your Q total divided by your individual capacitor, which is equal to 1.2 times 10 to the minus 3 divided by 60 times 10 to the minus 6, which equals 20 volts. Okay. Now to find W, which is your energy stored, is equal to 1/2 of your capacitance multiplied by the voltage for that capacitor squared. So that equals to 1/2 times the equivalent of 60 times 10 to the minus 6 times 20, and that equals 12 times 10 to the minus 3, and this number is in joules. So for the next capacitor, we'll use yellow, call that V2. V2 is equal to 1.2 divided by 30 times 10 to the minus 6. I'm sorry, this is 1.2 times 10 to the minus 3, negative 3, and that is equal to 40 volts. Same thing. Now we'll find W2, which equals to 1/2 times your capacitor, 30 times 10 to the minus 6 times 40, and that equals 24 times 10 to the minus 3 joules. For the last one, this 20 microfarad capacitor, we know that we have 40 volts, and we know that we have 20 volts. If we add those together, we get 80 from 120, leaves us with 60 volts. So we know that's 60 volts. We can go ahead and find W3, which is equal to 1/2 of 20 times 10 to the minus 6 times 60 volts. This gives us 36 times 10 to the minus 3 joules. Now, that is the energy stored by each capacitor. But you can also check yourself by checking the equivalent energy stored for the equivalent capacitor CT, and that is going to equal 120. We'll call that W total is equal to 120 volts. That's the voltage of the system, multiplied by your capacitance total, 10 times 10 to the minus 6, which is equal to 70 divided by 2, 72 times 10 to the minus 3 microfarads. So when you add this, and this one, all three of your individual capacitors, it will equal to this same number here. Thanks.